Well, good morning, everyone. We are moving on, talking about the last concept that we're going to discuss in this chapter. Now, I realize that in your notes there are some more areas that we originally were going to discuss, but we've decided to, as a group, take those out because we felt like you had enough information in this chapter to warrant doing a test over. If you see empirical formula and molecular formula, just disregard those in your notes because we're going to stop here with percent composition in terms of your notes. Okay, don't be alarmed if you see some extra notes that are not going to be filled out, that you will not be responsible for those on the exam. Okay. All right, so let's talk a little bit about percent composition. The percent by mass of any element in a compound can be found by dividing the mass of the element by the mass of the compound and multiplying by 100. So in a particular situation, if you have so many grams of a substance and you say, for example, we're going to use an example in a minute, magnesium oxide. And say, for example, you decompose magnesium oxide. Now you should know what that means based on the last chapter, meaning we're going to split magnesium oxide into magnesium and oxygen gas. So say, for example, you collected that oxygen gas and you were able to mass it out, get the weight of the oxygen gas. In the next problem, let's look at that. Let's see if we can figure out what percent each compound contributes to the overall mass of the compound. So percent by mass of each element in a compound is the percent composition of the compound. So it's talking about how much does each individual element contribute to the overall mass of the formula or overall mass of the compound. So we just learned about molar mass, where we're taking substances. So if you have glucose, for example, C6H12O6, right? What percentage of that sample of glucose is carbon? What percentage of that is hydrogen? And what percentage of that is oxygen? Or better yet, go back to what I was talking about a minute ago. If you have a chemical reaction, what percentage of that compound, like if I mass out so many grams of magnesium oxide, what percentage of that amount of grams that I have is magnesium, and what percentage of that is oxygen? That's what percent composition is. All right. So here's our example problem. So just what I was talking about, magnesium and oxygen. So if it's decomposed and I collect 5.4 grams of oxygen, what is the percent composition of this compound? So what they're wanting you to do when they give you that general term, they're saying, what is the percent of magnesium in that compound and what is the percentage of oxygen in that compound? Now, they're giving you two things in the sample. They're giving you the total mass of the sample, and then they're giving you the amount of grams of oxygen that was collected after the decomposition took place. Okay, so let's go to this next slide and show you what's really happening here. So the total mass of this compound was 13.6 grams, which they gave you in the problem. Then they told you that the mass of oxygen that they collected was 5.4 grams. So to find the mass of your magnesium, you would take the difference between the total mass and the mass of oxygen obtained in the sample. That would give you 8.2 grams of magnesium. So the leftover mass that you see in the difference, that's going to be the number of grams that you currently have of magnesium. So the next question is, what percentage of that is made up of magnesium and what percentage of that is made up of oxygen? Okay. So in this problem, you're going to take the mass of magnesium divided by the total mass of the sample times by 100, because anytime you're putting something in a percentage, you multiply that by 100. And that's going to give me 60.3%. So that is the percentage of magnesium in that compound of magnesium oxide. Then you go further and you say, okay, we collected 5.4 grams of oxygen. We're going to divide that by the total number of grams of magnesium oxide that we have times by 100, and that's going to give me 39.7%. Remember, when you're doing a percent composition, your percentages should add up to 100%. Now, sometimes you, with rounding and things like that, you might get it at 99.8 or something like that. That's okay. But you want to get as close to 100% as possible. Okay. So your rounding is a little important when you're doing this. All right. So that's an example. If you have so many grams of a sample and you're trying to figure out what percentage of each. Now, what per se if I give you a formula, okay? Well, you know how to calculate the molar mass of a formula where you're adding up all of your atomic masses. So that's what you see here in these pie charts. The number of grams of the element divided by the mass in grams of the compound multiplied by 100%. So what we did here is we had K, Cr, and O. And so what we did with the potassium chromate is I added up how much potassium is there, how much chromium is there, and how much oxygen's there. You add it all up to find the molar mass, and then you take each individual element divided by the total mass times by 100. And this is how we got these percentages for these two different compounds. Okay, so let's see how to actually do that. So percent by mass, mass of the element in 1 mole of the compound divided by the molar mass of the compound. Okay, this is if you're doing percent composition from a chemical formula. Okay, so let's look at this. So what if I have the formula propane? So I have the molecular formula of propane. The fuel commonly used in gas grills, one of the compounds obtained from petroleum. So it's asking calculate the percent composition of propane. When they ask you a general term like that, they want you to find the percentage of each element in the molecule. Okay, so we're going to find two percentages here, one for carbon and one for hydrogen. So let's see. So when I do the molar mass, you guys should already know how to do the molar mass. I see that I have 3 carbons here. So I'm going to say 3 times 12.01 equals 36.03. Then I'm going to take 8 times 1.01 and I'm going to get 8.08. I'm going to add those two together to get a total mass of 44.11. Okay, so this is my molar mass. Now I'm going to try to find the percentage of each individual element contained in the sample. So I go down here and I say, okay, what percentage of carbon do I have? So I go back up here, I take my 36.03, which is what I have of carbon, divided by the total mass of the molecule times by 100, and that gives me 81.7%. Next, okay, I have hydrogen. So I'm going to take the mass from up here of hydrogen, the 8.08, divided by the total mass of the sample times by 100, and that's going to give me 18.3%, okay, which remember needs to add up to 100%. Okay, so this is how you do percent composition. So following this video, you're going to get a worksheet on formulas that you'll be given, and you're going to be calculating just like this, the percent of each element within that formula. Okay, so refer back to the notes if you have trouble doing that. Okay, so go ahead, work on that worksheet and get that turned in. All right, so we'll see you later. The next thing you're going to be doing is a lab on popcorn. We're going to be showing you a lab on the percent of water in popcorn. Okay, so that's kind of interesting because most people don't realize that there's water in a popcorn kernel. So we'll talk more about that when we get to the lab. But so tomorrow you're going to have a lab on the percent of water in popcorn. All right, have a good day.